Hello viewers, once again welcome back to my channel Steam Mechanical. Today in this video I will be discuss about a very important topic which is taken from the heat transfer subject. Okay, so topic is the series and parallel connection of plane slab. In case of the plane slab, you can observe most of the time there is a number of plane slabs are connect. Okay, so maybe they are connect in series or maybe they are connect in parallel. So in such condition, how you can uh, go with such question? Okay, so first if we talk about the series connection, then how it will be look like. First of all, suppose if I consider this is the one slab. Okay, so please ignore the drawing. Okay, so this is the slab number 1 if I consider, and similarly if I consider this is the slab number 2. Okay, this is the slab number 2. Then now you say me that which kind of connection it is. So you will be said that it is a series connection, but I am say to you that it is totally wrong. Before you take any decision about the type of connection, please observe the direction of heat flow. Here I'm not said to you that this is the direction of heat flow. If I said to you that this is the direction of heat flow, then you can say that this is the series connection. So it is clear. Before you take any decision about the series or parallel connection, please observe the direction of heat flow. In the same case, if this is the direction of heat flow na, from top to bottom, then these will be convert to parallel connections. Okay, so this is the importance of the direction of heat flow. So in this case, if I take this is the direction of heat flow and this is the slab number 1 and this is the slab number 2, then this is in series connections. So for slab number 1, I am considering that this is the length L1, and for slab number 2 the length is L2, and similarly for slab 1 the thermal conductivity, okay, this is K1, and for slab number 2 it is K2. Okay, we have to convert it into electrical circuit. Suppose this is the slab number 1. For slab number 1 this is the resistance 1, and similarly for slab number 2 this is the resistance 2. Okay, R1 and R2, and this is the series connection. Now don't consider these are the electrical resistance. These are called the conductive resistance or convective resistance, but in this case these are the conductive resistance. Why these are the conductive resistance in this case? Because in this case we are talking about the slab means solid to solid. Okay, so here heat is transformed from, or you can say heat is transferred from here slab 1 to slab 2. So solid to solid heat transfer is takes place. So it is the case of conductive resistance. Okay, R1 R2 is here conductive resistance. So up to now it is clear. So if I want to convert this R1 R2 into single means equivalent conductive resistance, then how you can write it down? If I consider R is the equivalent resistance, then in case of the series there will be like that R1 plus R2. So just try to understand with an example. Suppose a job which you want to perform one after another. Okay, two job is there. First you want to complete one job, then you want to complete the second job. Means you can focus more on the each and every job. But in case of the parallel connection, what happened now? Parallelly means at the same time you want to perform the both the job, means your concentration will be less. Similarly you can use it here that if there is a series connection, means one after another your resistance will be more, means this equivalent resistance will be added, R1 plus R2. Okay, I hope it is clear to you. Am I right? Once again I am repeating it. In case of the series, your concentration will be more, because one after another. First heat will be transfer from slab 1, then from slab 2, means resistance will be, equivalent resistance will be add up. Okay, so equivalent resistance is equal to R1 plus R2. So here these R1 R2 what? The conductive resistance for slab 1 and conductive resistance for slab 2. Now you say me that R1 means the conductive resistance. How you can replace it? That length by thermal conductivity into area, cross sectional area. Now you tell me, just this area, this area is basically the area which is perpendicular to the direction of the flow. This thing you have to be remember. Okay, so this is for R1 means L1, because for slab 1 length is L1 and for slab 1 thermal conductivity is K1. So they are connected in series, so we are considering the area is same, means whatever the cross sectional area here and here both are same. Okay, similarly for R2 we can write it that L2 by K2 into A. Am I right? Now this R equivalent, then how you can write out? R equivalent means your total length L1 plus L2. Am I right? K equivalent, thermal conductivity for slab 1 is K1, for slab 2 is K2. If I consider that Ke is the equivalent thermal conductivity, then this equivalent thermal conductivity into area. Area is same here also. So this will be basically the ultimate equation. In this equation you can put the value of length, thermal conductivity, area, etc. Okay, or you can cut the area here also, you can observe it. Okay, so from here you can find out the equivalent thermal conductivity, or maybe any other things they can ask in the question. So based on the question you can find out anything which is based on this concept. Okay, series connection in case of plain slab. Now let's go to the parallel connection. So for parallel connection, if I consider this is the slab number 1 and this is the slab number 2. Okay, 1 and 2, and this is the direction of heat flow. Direction of heat flow is really important, already I discussed it. Okay, so similarly for if I take that this is the length. Okay, this is the length here. I'm considering for slab 1 and slab 2 length is same, it is L. So here it is thermal conductivity is K1 and for it is thermal conductivity is K2. Now in this case what will be happened? First you have to convert it into electrical circuit. So let convert it is, so for slab 1 this one, for slab 2 this one. Now heat is basically transfer from this end and this is the direction. Okay, and this is the basically end of the direction of heat flow. Okay, so this one, so this is resistance R1, resistance R2. Now in this case already I told that as in case of the series we can concentrate more. Okay, because one after another what will be happened, this is one after another. But in case of the parallel what happened, now whatever the direction of heat flow in both is same. Now whatever the amount of heat it is flowing through both the 1 and 2, means the concentration is less. If the concentration is less, means we can't add up the R1 plus R2. In case of the R series we are adding that R1 plus R2, but here we will be add the inverse of R1 plus R2. Inverse means 1 by R1 plus 1 by R2, and this is the 1 by R equivalent. Here also R1 R2 are the conductive resistance for slab 1 and slab 2, and R equivalent is the equivalent conductive resistance. So here also already we are write that R1 is equal to L1 by K1 into A and R2 is equal to L2 by K2 into A. So similarly we will be just put all those things here. So before put we can write it that R1 into R2, R1 plus R2. Can I write it? Yes, because R1 R2, R2 go here and R1 here. So R1 plus R2 by R1 into R2. So R equivalent, how you can write it? R equivalent is equal to R1 R2 by R1 plus R2. Am I right? So just simply put the values of R and R2. L1 by K1 A. Now here this R1 and R2, here L1 and L2 basically same. Am I right? Because length we are taking for both the slab is same. Into this one I'm just putting L2 into K2 into A. But here in this case one thing you have to observe, here length is same but area may or may not be same. Maybe first slab up to this one. Okay, if the first slab is up to this one, then this area is not similar to that area na? So area may be changed. Here you should write A1 and A2. Okay, so please be care about that. So L1 K1 A1 plus L2 K2 A2. So if you basically solve this one, basically most of the information will be present, any one will not be present, so you have to find out that query about. Okay, so this R equivalent, again you can write it if you want, that total L equivalent means total L is nothing but the L, and the K1 and K2 is nothing but your K equivalent into the area. Now this area you have to take the total area from here to here. Okay, total area. So this one equal to this one, you can here L1 don't write it, L1 again K1 A1 L K2 A2 and L K1 A1 plus L by K2 A2. So I hope this one is clear. Okay, so these are way, if in case of plain slab any question is come in your question where you have to feel that there is a series or parallel connection is present, then you can remember the concept. If series connection, first observe the direction of flow, this is the point number 1, then decide it is series connection or parallel connection. Okay, then convert it into, this is basically the step number 1, then this is the step number 2, convert it into electrical circuit. Then remember the concentration concept whatever I provide you, that if in case of series one after another means more concentration is possible, because at a time we are dealing with a single things. Okay, but in case of the parallel we are deal with a single time more than two or more than two things, means their concentration is less. So resistance in case of the series connection will be more, so we are just simply add those two, but in case of the parallel connection we are add the inverse of these two. Okay, and then simply replace the R1 by L by K into A, and you will be ultimately after some calculation you will be get such kind of equations. These equations are not important, the concept whatever I provide you, that the direction of heat flow and the electrical circuit, and then electrical circuit R1 write it in terms of the length, thermal conductivity and area. Okay, so in this video this much only. If you think that really video is helpful, then please like the video and subscribe my channel. Thank you.